All right, so there are lots of functions that we can talk about integrating and differentiating. Um, we haven't talked about the derivative of e to the x, right? Okay, so yeah, we got so much to talk about. But let's just review some rules regarding logarithms. First of all, the natural log function is defined by natural log of x is equal to the integral from 1 to x of 1 over t dt for x greater than 0. Okay, the name of the natural log function is the set, or rather not the name, that should say the domain of the natural log function is the set of all positive real numbers. Okay, so properties of natural log, which you've studied before, the domain is from 0 to infinity, and the range is all real numbers, minus infinity to infinity. The function is continuous, increasing, and one-to-one. Because the function is one-to-one, that means it's going to have a what? What do you have to, what do you have to be one-to-one to have? No, an inverse, okay? In order to have an inverse, the function must be one-to-one. Or in order to have an inverse that is a function, the function must be one-to-one. And then now we can apply this new terminology. The graph of natural log is concave down. Okay, so we can see that. So when we graph natural log, if this is the basic graph of our natural log function, okay, notice that the domain is positive real numbers, right? So we've got an asymptote here at x equals 0, but it looks like the function is defined for all of these positive x values, right? And the range is minus infinity to infinity. So it's going to keep going down here and then keeps increasing as we draw it out farther here. It's going up higher. Okay. How do I look at variations on this graph? Well, we can just do our shifting, right? Remember talking about transformations of graphs in Math 110? Okay. Like for instance, this plus 1 is going to do what to our graph? Shift it up by 1 point, right? And this minus 2, which is inside, it's tied to the x, it's going to shift it which way? To the right. Okay, going to shift it to the right. So if I wanted to draw this, I would take my key point. Okay, I'm going to go up 1 and then right 2. Okay. All right, and then I can do the same thing with this asymptote. Okay, of course, there's no need to move it up because it's going up forever anyway, but I can move it right 2. Here's my new asymptote. And so the graph continues that same pattern going through this point. And so that's an easy way for us to get a transformation of that graph. Okay. All right, so some log properties. Again, all of this is just a review of algebra, but the natural log of 1 is 0. Okay, when we talk about logs, just as a reminder, okay, for natural log, the base is what? Not 10. E, very good. So when I say natural log of 1 is 0, what I'm asking is, what is it that I raise e to get 0? Okay. The answer to a log is an exponent, right? So what can we raise e to that's going to give us, I'm sorry, not 0, but 1. And x would be what? 0. Okay? So that's why we say the natural log of 1 is 0. E to the 0 is 1. Okay? So that's a property. Another property is the natural log of a product. I can distribute logs over a product, but it becomes a sum. Okay, so natural log of a times b is equal to natural log of a plus the natural log of b. Okay, the natural log of a to the n, okay, almost feels like taking a derivative, but it's not. This is just an algebra rule. We bring n out front times the natural log of a. All right, so we use this a lot when we're trying to solve for a variable that's in our exponent. Okay, I can take the natural log of both sides, and that'll allow me to bring that variable down. Okay, and then a natural log of a quotient, I can distribute a natural log to the quotient, but it becomes a difference. Okay, all right, so those are some natural log properties that you're probably already familiar with. Okay, use the properties of logarithms to approximate the indicated logarithms given that natural log of 2 equals 0.6931 and natural log of 3 equals 1.0986. Okay, I'm not sure what that mark is there. Huh. Oh no, I don't think that's anything. Okay, so we're just going to do natural log of 2/3. Okay. So the natural log of 2/3 is equal to natural log of 2 minus natural log of 3. Okay, that's what that quotient property told us. I can distribute it to my quotient, but it becomes a difference. And so we get 0.6931 minus 1.0986. Okay, and whatever that is on your calculator, we can do that. Okay. Questions about that? All right. Okay, if I have natural log of the square root of 3, well, I could rewrite the square root of 3 as what? 3 to the 1/2. So we've got natural log of 3 to the 1/2, and if I use that rule for my powers, this becomes 1/2 times natural log of 3. Okay, and so they've given us an approximation for the natural log of 3. Okay, so whatever 1/2 of 1.0986 is, that's what we would get as our answer. Okay, questions about any of those?
Natural log of 3, that's the actual value, or is that arbitrary?
I would hope that I calculated it correctly. But in this case, they gave it to us so that we could just, okay, on a small calculator, is that your graphing calculator? Okay, yeah. So, you see it? Okay. All right, very good. Okay, down here, we've got more properties of logarithms to expand the expression. Okay, so nothing in particular, no value that we're trying to get, but we want to be able to expand it. So I would rewrite this first as the natural log of x to the 5th to the 1/2. Okay, and so we could write that as what? Okay, we multiply the exponents, so we could say natural log of x to the 5/2, right? And then, according to that property we saw, this becomes 5/2 times the natural log of x. Okay. All right, what about the natural log of 3e squared? Very good. Okay, so natural log of 3 plus the natural log of e squared. Okay, now, and then what would we do? We can do what? We can bring it out front to natural log of e, but what do natural log and e do to one another? They cancel each other out, right? So we get the natural log of 3 plus 2. Okay, natural log of e to the x is just x. Okay, in this case, the natural log of e to the first power is just 1, because natural log and e, they cancel each other out. Okay, so we get natural log of 3 plus 2. All right, so we can use that natural log to expand things. All right, now we're going to go in the opposite direction. Okay, we're going to use natural log to compress some things. So thinking backwards, we get what? If this was 3 natural log of x, I could get natural log of what? X to the third, very good, plus, okay, natural log of y to the second, minus natural log of z to the fourth. Okay, so we kind of undid that power rule. Now, looks like we've got natural log distributed to all of these terms. We've got the first two are positive, the third one is negative. So what do you think we're going to get? Okay, natural log of x cubed. Say that again. Okay. All right, very good. We multiply, and then what are we going to do with the z? Okay, this is divide by z to the fourth. Okay, so we just undid the product rule and the quotient rule for our natural log function. Okay. All right, why don't you try B on your own to make sure we're all on the same page. Okay, how many people got that? Okay, all righty. I was careful. We had to be careful. But, I was trying to decide when I looked at this piece, is this going to be a product or a quotient? Okay, well, we had two pieces that were subtracted, so I decided to factor out the minus there. Okay, so when I did, we had minus natural log of x plus 1 plus natural log of x minus 1. I was able to put them together as a product, but this whole thing was still subtracted. So that means all of this was going to go into my denominator. X squared plus 1 stayed in my numerator. And I could go one more step and do what? Okay, make it a power. So we get the natural log of, I guess I should say, x squared plus 1 over x plus 1 times x minus 1 to the 3 halves. Okay. All right, questions about that? All right, very good. Okay. All right, so we've got the definition of E stated in terms of integration. It says the natural log of E is the integral from 1 to E of 1 over t dt equals 1. And we're going to talk more about that as we look at integrating things that involve natural log. Okay, so Before we're going to integrate, though, we're going to take the derivative. All right? The derivative of the natural log function. It says let u be a differentiable function of x. Okay? Well, the derivative of the natural log of x is just 1 over x. Okay? Now notice, remember when we've been integrating, we've never integrated x to the negative 1. Right? What happens if we tried to use our power rule on 1 over x dx or x to the negative 1 dx? What would happen if we tried to do that? We'd get 0 as our exponent and we'd end up having to divide by 0. That doesn't work, right? So if you look back at your power rule for integration, it said except for x equal to negative 1. Okay, so we can't use that integration rule or the power rule when we're integrating x to the negative 1. So how are we going to integrate that? Oops, I lost it. We're going to integrate it using, well, I'm jumping ahead, but we're going to integrate it using natural log because the derivative of the natural log of x is 1 over x. Okay, the derivative of the natural log of x is 1 over x. And so in a little while, we'll turn that around. Now, if we have, instead of just this simple x, some function, then we're going to have to use the chain rule. So we're going to say 1 over u, and then we got to look at the derivative of u. Okay, and often what we end up with is a function where we have u, or the derivative of u up top, and u to the first power on the bottom. All right? But again, I'm kind of looking ahead to the integration. But we're going to first look at the derivatives. Okay? So let's say I want to find the derivative of the function. Okay, we got natural log of x minus 1. Then f prime is going to be 1 over x minus 1 times the derivative of x minus 1, which is just 1. So we say 1 over x minus 1. Okay. All right, the derivative of natural log of 2x squared plus 1 is going to be 1 over 2x squared plus 1 times the derivative of this, which is what? 4x. Okay, so we might write that more concisely as 4x over 2x squared plus 1. Okay, and this is what I mean when I say, notice that we've got 2x squared plus 1 to the first power on the bottom, and up top we've got the derivative of that, which is just 4x. So just start kind of training your mind now. When I see that, then the integral is going to be the natural log of the thing that's on the bottom. Okay, if it's to the first power on the bottom, and I've got the derivative up top. Okay. Can you catch these? Yes. All right. So what happens then if I combine this with, another function like x squared? So we've got y equals x squared times the natural log of x. I'm going to need to do what? What is it? Product rule. That's right. Okay. So we get y prime equals the first. X squared is going to be my first. Natural log of x is going to be my second. So first times the derivative of the second. Well, the derivative of natural log of x is just what? 1 over x. Okay, so first times the derivative of the second plus the second times the derivative of the first, which is 2x. Okay, and we can try to clean this up a little bit. I'm going to get x plus 2x times the natural log of x. Okay, and I'll just leave it like that. Okay, questions about that? All right, so in D, we would need to use what? Quotient rule. Okay, so h prime of t equals low derivative of high. Well, the derivative of natural log of t is 1 over t. So low d high minus high d low. Well, the derivative of just t is what? 1, okay, all over low squared. Okay, so we clean that up. The t's are going to cancel. So I've got 1 minus the natural log of t all over t squared. Okay, questions about this? Okay, so it's not a bad derivative rule, right? As far as rules go. Oh, we got some more, yay. All right. Which one do you want to try on your own, E or F? Okay, F is the one you're going to try on your own. Okay, so I'll do E with you. All right, so we got to be careful here. Um, the first part is going to be easy, but what rule are we going to have to use overall? Chain rule. Okay, very good. All right, so because we're going to have to use a lot of things. We've got the natural log, then we got what's on the inside of the natural log, and then this thing on the inside of the natural log is a what? Product. Okay, and then we even have this thing that has a power. So this is going to be fun. Okay, so we got y prime equals, natural log is on the outside, so I'll start with 1 over t times t squared plus 3 cubed. Okay, so now I come inside to where I have a product. So I'm going to apply the product rule. That's first times the derivative of the second. So that becomes what? Okay, 3t squared plus 3 squared times 2t. Okay, all of that was the derivative of the second. Okay, so first times the derivative of the second plus the second times the derivative of the first. Okay, I think we're done. All right. I mean, we can clean it up, but as far as the derivative goes, we're done.
The derivative of the first, that'd be 1 over
It'd just be 1. Now when we did natural log, we did 1 over the whole thing. So we took care of the 1 over t here. But now we're done with natural log, and so we had to take the derivative of this inside piece, and we just used a product for that. Mm-hmm.
so natural log is like cosine x time.
Yes, it's natural log of something. Okay. All right, so when I clean this up a little bit, I've got t squared plus 3 squared and t squared plus 3 cubed. So I'm going to factor out t squared plus 3 squared. Okay, so I factored that out. That leaves me with 6t squared. Is that right? Okay. Plus what? What am I left with over here? Come on. T squared plus 3, right? because we factored it out to the second power. So I'm left with 1 over there. Is that right? Okay. Alrighty. Okay, so we'll cancel a little bit. That goes away. I'm left with 1 here. And then up top, I've got 7t squared plus 3 over, we could leave it factored if we wanted to, t times t squared plus 3. All right, and I'm done with that. Okay, questions about that one? Mm-hmm.
So what do you cancel on the bottom but the second row from last step? Cancel the 2 out with what?
I canceled, well, both of them were t squared plus 3. Up top, I had it to the second power, and on the bottom, I had it to the third. So I was able to cancel, except on the bottom, I'm left with 1. Mm-hmm. Okay, other questions? All righty. Okay, so here we've got f is y equals the natural log of the cube root of x minus 1 over x plus 1. Why don't you give that a shot on your own? Okay, so I started out by doing 1 over my function, okay, but I need to know that this is the natural log of, let's write it this way, x minus 1 over x plus 1 to the 1/3. Now, before I go on, is there something else I may do that might help me a little bit? Pull out the what? The 1/3, right? Okay, we can use those algebra rules that we just talked about. This is still 1/3 times the natural log of x minus 1 over x plus 1. Okay, so that way, when I start my derivative, it's going to be y prime equals 1/3. Now is just a constant multiple, okay, times 1 over x minus 1 over x plus 1. Well, what is that? Say that again. Very good, right? We just take the reciprocal. Okay, x plus 1 over x minus 1. Okay, 1 over this thing flips it over, right? So we get x plus 1 over x minus 1. Okay, so that's where I did the natural log derivative right here. And now the only thing I have left to do is my quotient rule. So we do low d high minus high d low all over low squared. Okay. Let's see, low d. Well, no. This is our low and this is our high. Well, no. When I took the derivative of 1 over, then it became this. But our original function, the low was x plus 1 and the high is x minus 1. Okay. All right, and so we clean this up some. 1/3 times x plus 1 over x minus 1. And this looks like it's going to be x plus 1 minus x plus 1 all over x plus 1 squared. So we get 1/3 times x plus 1 over x minus 1, okay, times what? This numerator is 2 over x plus 1 squared. Okay, and I think I can cancel one of these x plus 1s, this one with, okay, 1 down here in my denominator. And so we get 2 over 3 times x minus 1 times x plus 1. Okay, how many people got that answer? Excellent.
I thought x plus 1 over x minus 3 times 1/3 was the derivative.
Say again.
I thought that was the full derivative.
Where? Right here?
Yeah, just that part.
It is, and then after that we simplified it. So yes, when we did this, it was the derivative, and then when we did this, we cleaned it up a little bit. That was still the derivative. All of these are the derivative, but we simplified it to this. Okay.
The chain or the quotient rule.
I did use the quotient rule right here.
Maybe the second derivative.
No, no, no. We were doing a chain rule. So, okay,
Yeah, because you gotta do the derivative.
right. Okay, questions about that? Okay. Alrighty. All right, there's a new rule. Oh, yes. Implicit differentiation with natural log. That's going to be beautiful. Okay. All right, very good. Okay. So, pretty much once we look at the derivative of natural log, we'll just look at several log derivatives and also integration. We ought to be able to finish that next Monday. And so I may make it at least 2 homework assignments. I'll try to limit it to no more than 2 for chapter 5. Okay?